Right now, you're watching this on an electronic device. Do you ever think about where it'll end up when you're done with it? Many devices contain toxic materials and should be recycled very carefully. Sadly, lots end up in landfills. But even if you're diligent and give your electronic waste, or e-waste, to a recycler, that's no guarantee about what happens next. Americans throw out millions of tons of electronics every year, and export abroad is still a big problem. Take, for instance, LCD monitors that contain mercury. If a worker in, say, Hong Kong smashes it, poisonous vapor can be released into the air. Workers dismantling electronics can get severely sick and even die.
Pollution, it does harm people. Nobody quantifies it, and it's really hard to quantify how many deaths or disease. But it is a form of murder. When people die from this, and they'll die prematurely, the data supports the fact that these pollutants do cause death and disease.
Assalamualaikum and hello everyone. My name is Shahril bin Saidin. I am a postgraduate master student in University Malaysia Terengganu and currently on my first semester of my studies. In this video, I would like to share about my project for MPI 2021. The title of my project is CSAB, stands for Conjugated Disubstituted Alkoxy-Bichalcone as Active Emissive Layer in OLEDs Application. This is the outline of my video, starting with general informative and will be done with conclusion. So, what is OLEDs? OLED stands for Organic Light Emitting Diodes. It's a flat light emitting technology that consists of organic thin film between two electrodes. When electrical current is applied, light is emitted. Nowadays, OLED technology are well developed in many applications such as mobile phone screen, television screen, light panel, and so on. However, there are several current issues that has triggered us to projecting this innovation. First is limitation of fabrication technology. Second is non-environmental friendly that give the huge impact for human and environment due to usage of organic metal OLEDs. Third is higher cost in productions of OLED. And last but not least is low lifetimes, which downgrade the performance of OLEDs. Therefore, we introduce the CSAB product as our devotion in innovation of OLED material. CSAB compounds are classified in chalcone group, which consists of carbonyl and alkene functional group in their molecular backbone, as we can see the figure of CSAB compound. The reason of why we use CSAB as an active emissive layer because of the alternation of bond in molecular framework resulting to high mobility in charge transfer. The CSAB also attributed by d-pi-d system, where the donor ligand will donate the electron to pi ligand, make it pack with electron. As we can see the Schlieren texture below, CSAB also exhibit liquid crystalline behavior, where this behavior proven the CSAB has great luminescence properties. Hence, it can emit light when connected to electrical current. Here is the pathway of the production of CSAB product and their fluorescence and luminescence behavior. This is the difference between CSAB with polymer LED in aspect of synthesis and handle, production costing, performance including lifetime and efficiency, and environmental friendly. So, how do we want to know that CSAB functionality as emissive layer of OLEDs? Actually, we have done OLED testing via typical instrument to measure their voltage and IV curve, light testing, and fluorescence behavior. Now, we are going to watch a video about OLED testing. Next is sustainability, which the production of CSAB give advantage in eco-friendly environment production with thermally stable, give social opportunity to use high current voltage system with great performance, and give advantage in economic, which is low costing of production and sustainable production with high turnovers. This is the usefulness and contributions of CSAB product. For novelty and inventiveness, CSAB is a new dye-substituted compound and it is the first OLEDs product based on CSAB single molecule. CSAB is of production with low cost and high purity, and it is a simple conjugated compound that promising as candidate for an active emissive layers in OLEDs. This is the highlighted feature that featuring the CSAB product. We have registered our product with my IPO, but unfortunately the copyright is still pending. It is the notation that CSAB as a new productions of active emissive layer of OLED. In the conclusion of our project, CSAB consists of simple conjugated compound that promising the innovation of OLEDs material. CSAB has proven as an conductive material, and CSAB is safe to human and environment and thermally stable.